Hello everyone and welcome to my session, Hey, you can't go there, on this year's Global XR conference. Today's session is all about moving in VR and specifically moving to places where you are not supposed to go. This is a problem very common to VR apps and games, not so much in mixed reality or AR applications. So we will be focusing on VR apps and games in this session. Now, this is a pre-recorded session, so make sure to write down any questions you have, post them in the Discord, in the Global XR Discord, or find me online on my social media channels. I will make sure to include in my slides my pillar.io link, and then you will be able to find me everywhere using that link if you have any questions. Yeah, thank you for watching, and let's get started. All right, so let's take a look at why our players cannot go wherever they want inside our apps and games when in VR. This is our agenda for today. We will take a brief look at locomotion in VR, very brief and basic, and then we will define what our problem is actually. And then we will talk about a proposed solution and see an example implementation of that. And then that's already it. We will wrap up at that point, and you will have learned about, techniques to prevent users from going where you don't want them to be. So let's first define what is locomotion in the context of a VR application or XR, if you like. So it's methods and techniques that allow our users or players to move within our virtual environment, but their physical space is limited. So they won't, unless they are playing outside on a huge field, they will be limited by walls. There might be tables, chairs, I don't know, a couch. There might be a lot of stuff that's limiting the user's space to move around freely. So locomotion is all about allowing our users to virtually navigate our world without having to move physically. And at best, we do that without causing a lot of discomfort to the player or the user, because moving visually without moving your body can actually cause a lot of discomfort with many people. And it's one of the main issues that still needs to be solved probably in VR, if you like. So here is an example of me using smooth locomotion. So my Quest is connected using Quest Link to the Airlink to my PC, and I'm just using the Unity editor to press play. And I'm here in this demo. I'm walking around using smooth locomotion. That means I'm actually not moving physically. I'm just orienting myself. I'm rotating my body, maybe moving slightly, but not a lot. And I'm using that to, point at where I want to go. And then I'm using the thumbstick on the controller, on the Quest controller right here, to move smoothly as if I was walking. So that's what we call smooth locomotion. Here's another example of a very popular technique. You probably saw it a thousand times. Teleportation. So what we see here is, I don't know, I would say blink teleportation. That's at least what I call it. So we fade the camera out, move the user to a different position and orientation, and then we fade the camera again to fade it in, and the user can see where they are. So basically we move them from A to B without them noticing, and instantly it happens within a single frame, and then that way they can travel a really large distance. The smooth locomotion that we saw before is suited, when you want to simulate walking and stuff. But if it's really far away where you want to go, or if it's on an upper level and we have to, there's a difference in height, then we might prefer using teleportation for that, where the user uses the controller to point, like fishing. Basically, they point and throw a rod to where they want to be, and then they are moved to that position. And they can use the thumbstick on the controller again to also define how to orientate the camera when at the target location. So that was a very quick look at locomotion. What we are seeing here is basically that our virtual world, the green area in this picture, is much larger than the physical space, the red space in this picture that we have. And that's where our user is. So they have limited physical space, but a much larger virtual world. And locomotion is solving that problem by basically moving that red square around and moving the user's physical space around so that they can reach other areas of the virtual world. So in this picture, what we see here is a top-down view on one of the game MVPs prototypes I'm currently working on. It's a river, and there is a boat on the river. And actually on the boat, there is this square area, which is now highlighted green. And that is essentially the virtual world I want the player to move in. It's 2 square meters. It's enough space to move around a little, and it doesn't require large play spaces because I want my players to be able to play this game at home. They shouldn't require a lot of space, And 2 square meters, I think everyone has that at home somewhere to play. And in this case, as I said, I want the player to stay where the green area is. But as it happens, the user's actual physical space is the red area, is much larger than the area that I have defined where I want the player to be. And this is actually where the problem we are trying to solve today, and that we are talking about today. We don't want the user to enter the front part of the boat, or to leave the boat into the water or stuff. We actually want them to stay inside that green area. But with VR, since we have track devices, 6 dimensions of freedom, we cannot prevent the player physically from moving around. So if there is a wall, okay, it will stop them. But if there is no wall and no obstacle in the physical space, they can actually move off the green area and onto the water or whatever. And there is no way for us to prevent that. With classical locomotion, smooth locomotion, and teleportation, we have the means to, programmatically restrict where the user can locomote to, where they can move to. But with physical movement, as of now, no device has the ability, and I doubt it will ever have, to prevent the user from moving. So another quick recording, seeing that problem in action. Again, me using my Quest, and I'm standing on the vessel. And as you can see, I'm moving off the boat. I'm now standing above the water, and I'm basically already falling into the water, and that's what I never want to happen. I don't want players to go there. I want them to stay inside on the boat and not leave onto the water or any other area. And that is what we are going to propose a solution for now. Okay, so we have talked about locomotion, we have talked about the problem at hand, and now let's look into a proposed solution. This is, of course, just one of many solutions one could tackle, but I think it's pretty flexible and can be used in different scenarios. So, yeah, let's keep going. Enough talking. So, this is just for this specific scenario that I just showcased. I think we could actually get away with a very, very simple solution, which is just, we always know the offset of the user to the origin. So if we define our origin of the play space at the center of that green area, then we can always know how far is the player away from this origin, or what's the local coordinate space position of the player. And that's enough actually for this simple scenario, because then we can basically, based on distance, know if they are off the boat or on the boat. This solution, however, is only going to work for this specific scenario where we have a really simple play space. Now imagine a real open world game, or at least a game with some actually playable level design and area that you can explore. And then you could never just, define one specific origin and then calculate distances and stuff. So that's going to fall apart very quickly in a more complex scenario. So instead, what we are going to do is we will define borders for our play space using invisible colliders, using triggers that are placed in our environment design, and that will tell us when the player is about to exit the available or play space that we want them to be on. And in this scenario, we will just put simply a square, 4 colliders around the play space, and that's it. But of course, in a more complex scenario, which we will see in a minute, we can use, we can, any shape of environment we can replicate and place borders around that will help us keep the player in line. So for this solution, I will be using the Reality Toolkit, which is an open source Unity toolkit that I'm contributing to. However, as you will see, the principle is the same, and even if you go vanilla and implement this completely on your own, it doesn't matter whether you are using Reality Toolkit or some other toolkit or just Unity as it is. It's fairly simple to implement and replicate. I will briefly talk about the Reality Toolkit just to introduce it, and then we will move on. So the Reality Toolkit, as I said, is an open source framework for Unity that is focusing on XR, app, and game development. It's cross-platform by heart and design. That means every feature that is available in the toolkit will work on any platform. So we are not adding features that only work on Quest, that only work on Pcore and whatever. They work across all platforms. And that is the important part here. So once you have a Reality Toolkit based application or game, it will deploy fine to different platforms without additional work needed. The toolkit is maintained and controlled by the community. a bunch of contributors at this point, and there is a Discord where things can be discussed. There is no company controlling it. It's just a community of developers. And yeah, it's for use with the Unity engine and editor. It's actually like it started out as a fork of the MRTK, but it went its own way at this point. It's derivated a lot, and there's still the core concepts that you will see are familiar to MRTK users, but it's quite different in some other areas as well. It's like a love child of the Unity XR interaction toolkit and MRTK basically. Yeah, so as I mentioned, this is the domain. You can check it out there and see some docs. It's maintained on GitHub, and there is a Discord to discuss questions and issues you might have if you're using it. Real quick look at how to set up your Unity project to use it. Simple enough. Go into your project settings in the package manager settings, add the OpenUPM scope registry, and make sure to add the com.reality toolkit and com.reality collective scopes. The reality collective is the group of developers, developing the toolkit and the service framework. And that's it. So once you added that, return to your package manager in Unity, and you will see a bunch of packages available from the Reality Collective. Most of them are related to the toolkit. Make sure to install at least core and camera. So reality toolkit.core is everything foundational to the toolkit, and camera will give you XR player controller and some other stuff. Actually, the XR player controller is already using this implementation that we will look at right now. So what we will see in this session next is available out of the box with the toolkit actually. So you don't have to re-implement it yourself. And also I recommend checking out the locomotion package, which comes with smooth locomotion, 3 kinds of teleport locomotion, and teleport anchors and stuff. So everything that you've seen so far in this presentation was using the Reality Toolkit, and it's all out of the box available. So there was no customization at this point in what I've shown. So pretty cool to get started and implement VR and XR applications. Yep, and once you have installed that, you can just confirm that prompt to install TextMesh Pro Essentials because they are needed by the toolkit, and wait for import to complete. Just a tip that I discovered recently, I wasn't aware until recently. By now in the Unity package manager, you can actually select multiple packages and install them at once, or update them at once and remove them at once and stuff. So previously you would install one package, then you had to wait for it to complete, then you selected the next one, and then you installed that one, and so on and so forth. Now you can just select 10 of them, select install, go drink a coffee, and then return for things to be ready. Yeah, and once it's in your project, everything's installed, just open your scene and navigate to Reality Collective, Reality Toolkit, Configure in the menu toolbar in the Unity editor window, and then your project is ready to go and the toolkit is configured and installed. You will notice that your main camera was removed and replaced by the XR player controller, which is a prefab that is used by the camera package of the toolkit and has, player collision, navigation, camera bounce, and stuff. So it has a lot of stuff pre-made for you and ready for use. Yeah, that was a quick detour to the Reality Toolkit. This is an image of the sample scene. So there's a sample scene that you can check out with everything that the toolkit has to offer in place, and then you can just navigate around and explore on your own. Okay, back to topic. Let's switch to Unity and take a look at how we can implement this solution to our problem. Okay, we will start in Unity by just creating some simple I don't know, level layout. Just mock something up real quick. This, I think it's 10 and 10, so I can do this. No, sorry, I got confused. So that's that. And then -5 like this. Actually, I want to keep this one open, I think. And just do this one like this. This. 5, 5. This is -5. 180. Sorry. Okay. So this will be our initial layout, I think. Oh, this one has to go. Sorry. This is what I was going to do. This. So we now have like a box, and we will continue from here, going like this, and then we will duplicate this wall and move it up 10 and rotate it by 40 -45 like this, and maybe get this one, and we will update this one again. This, yeah, I think you get the idea. So this is already enough. Actually, I want to add here a little border sorts of, so we oh, that's the wrong one. So we can simulate a fall. So okay, so we will restrict the player like this, like it was a balcony or something that we can look down to. So we can already see that where we want the player to play. It's inside this area and inside here, and they can look down here, and they are not supposed to go behind these walls, because then they would actually see that it's a virtual world and they are living in the matrix. So we want to prevent that. So in the next step, we will position the bounds triggers. So those are simply default Unity box colliders, and there is this component camera out of bounds trigger, which doesn't do a lot. It just detects whether the player is entering that trigger, so that's how we will determine whether they are leaving the designated play space. So we will now increase this to 10, and this one also to 10. That should be enough. Then we can start doing some layout here. So position this one here, then I duplicate it, rotate it a little, move it on the x-axis by 5, and return here. Then I duplicate that one as well to the other side. So let's select all three. So this is what we have right now. So we have already set up bounds, play space bounds for this area. So we will now keep going and duplicate this one like this. Actually, we can just copy the position of this tile and then paste it here, and then just add the rotation to it, and that's it. And then we do the same thing over there, duplicate it, move it by 10. So I think we are getting close. Yeah, so like this. Then we can actually duplicate this one again and copy coordinates of this one and paste it here. Oop, So now we have almost all of it, and now we just want to make sure that this board balcony is also say a safe zone. So we just duplicate this one more time, rotate it like this, move it a little. It's not important. It doesn't have to be precise. And that's it. So right now this looks like this. It's very rough. Of course, you could put more work into making it as detailed as possible and add some more effort to it. But I think you get the idea. So it's now a complete. It's like, I'm sorry, I'm missing the word. It doesn't have any holes basically. That there's no way the player can escape without triggering any of those colliders. And no matter what your level layout looks like, you will be able to create this kind of layout with box colliders. You will just need either plenty or a few. Okay, so we now have set up that as well. Okay, so now I'm again on my quest. I've just pressed play using Quest Airlink to launch this level on my device and play. And I'm using controllers to perform locomotion. As you can see, I can walk around, and if I bump into this wall, I can't go any further. So it's blocking me from leaving this level. That's what we can perfectly control. It's not a big deal. I can use teleportation to move around. So that works as it should. And now even if I go to this balcony and get to a stop, because my player controller, my character controller, it bumps into this wall and I cannot move further. I want to make sure you guys see this. Okay, like this. So I cannot get any further. But what happens if I go physically try and move beyond this border? I'm hoping you guys can see that in the recording. It's fading to black. So I'm basically trying to exit this area. I will look to the right. And you can see as I go beyond this balcony border, it starts fading out my camera view. So that's what I went with here. I just want to occlude what the player sees when they are. I don't want them to see the ugly stuff. Of course, in a real world application, you could now add, some text indicator, some arrow maybe that tells the player, please return to the play space, and shows them how to. That's very important. Show them in which direction to return. Or you can start a countdown basically, and then once that countdown has passed, and if the player still has not returned to the safe zone, to the play space, then you basically force them back into the play space, which is something you can do. And you should always do that smoothly, since you are already faded out. You just put them back while it's faded out, and then you fade in again, and they won't even notice they've been moved basically. So that's that. So that's how our system is currently working. All of that is in place, and we will now look next into the code, how this is accomplished, and how you can make use of it to extend it for your own scenario, for example. But so we can see already a working system to prevent the user from leaving the area that you have designated for them to play in. Okay, now that we saw how this works, let's look at the code, how it's implemented. I won't be live coding it right now because it's easier to look at the existing code and just walk through it. It's not a lot, I promise. And live coding is always tricky, especially since it's recorded. It can't even be live. So let's go and take a look at Unity first. So we have the XR player controller, and most importantly, we have the XR player head, which is used to detect when the player moves inside a trigger that is telling us that the player is leaving the designated area. So as you can see, this head has a sphere collider, nothing special here. It's the track pose driver that makes sure essentially this camera is the player's head, right? It's sorts of that's where the headset is, and on this game object there is the XR player head. So let's take a quick look at that and see what that looks like. Yeah, so that component, it just has a reference to the collider, and then it has yeah, some initialization logic here. It gets this camera bounce module, which is a service that is managing whether the player is inside or outside the camera bounce. By camera bounce, I mean the area that the camera is supposed to be within, right? And then when we have this event, camera back in bounds, that we subscribe to, because when the camera is back in bounds, we want to make sure that we reset everything properly to return to a neutral. And essentially where the magic happens is on trigger enter and stay. This is where we take a look at whether we have already registered a camera out of bounds trigger. And if we already have registered it once, that means we are already, inside a camera bounce trigger. And already it's registered that we are leaving the camera bound area. Then we don't need to worry about additional triggers. So essentially that's what we do here. So if we don't have an initial trigger yet, then we save a reference to that trigger and we save the enter position. We use the enter position to reset the player into the camera bounce, into the play area if needed. So basically we can use that value to force reset the player into the last known valid position before they left valid bounds. And that's what we do here. And on trigger state, does some additional math to calculate a severity. That means it calculates how much is the player already inside our bounce trigger. So if it's just barely touching it, then that means we are still somewhat okay. But if it's already passed through it or already halfway through it, that means we are already pretty much out of control and we need to take measurements. So yeah, so whenever this updates, we raise an event, camera out of bounds, that includes the information how severe the situation is and contains the direction vector that indicates how to return to a valid position. We can use that to display an arrow, for example, that tells the player how to return. And then we have on trigger exit, obviously that just fires raise camera back in bounds. And when the camera is back in bounds, we just make sure that we reset the initial trigger properly. So that's what the XR player head does. Let's take a quick look at the out of bounds trigger. Nothing special here. It has one serialized field inspector setting, which is raise events, that we can also programmatically set to true or false. And this is used for an additional feature, basically. So you can have bounds that are valid in a given situation. And then, for example, the player unlocks the next area of your level, and then you want to make sure that some of those camera bounce triggers are disabled because now the player is allowed to enter that area, for example. So you can even use this feature to basically control the level flow and make sure that the player only progresses as he or she unlocks new areas. So that's what this does, camera out of bounds trigger and XR player head. And the glue for all of this is the iCamera bounce module, which is a service for the service framework and part of the reality toolkit. It has camera out of bounds, true or false, so we know what's going on. We know it gives us, if we need to, the last in bounds pose of the camera rig, so we know where to move if we want to force remove. It has an event for camera out of bounds and an event for camera back in bounds, and that's it. And it also has an API to reset camera into bounds. So you can use that to force the camera back into bounds. We already took care of that if you want to use that. And it has the camera out of bounds raise handle that basically forwards the event to all subscribed delegates. Same here. And that's basically it. That's the interface of the camera bounds module. We can take a quick look at the implementation, but it's rather simple. So in update, we are checking if we are out of bounds, then we do nothing. And if we are inside of bounds, then every frame we save, make sure to save the valid position of the rig. Because as long as we are not out of bounds, our position is valid. And that way we can save last in bounds pose. Yeah, and that we use down here to reset camera into bounds. Now, all of this you will likely just use. It's just a bunch of events going back and forth and using regular Unity physics to use triggers and detect collisions, basically. But how do you use all of that if you want to implement your custom, handling for this kind of situation? So you can take a look at the camera fade. I think that's what I call it. Camera out of bounds fade, which is a mono behavior that I attached to the camera itself. And it basically just subscribes to these two events, camera out of bounds and camera back in bounds. And then it uses this camera fade component, which is just a component that puts a black plane in front of the camera and fades it in or out, depending on what you need. And it just uses the severity of the camera out of bounds event to set the fade of that camera fade. Just a really plain and simple way of using this event and the severity value to fade out the camera. Of course, just fading out is not the ideal solution because the user doesn't have any clue what's going on. So you really want to make sure that you then used the return to bounds direction and an additional text UI element that basically tells the user what is going on and how to resolve the situation. And that's how you can achieve that. Yeah, so let's go back to Unity. So really, it's just 4 components in play here. The camera out of bounds fade handles the updates. We have the triggers that detect when the camera is moving out of bounds. And then we have the player head, which is basically causing the detection and is where the player is. And that's it. And I'm not going to talk about the toolkit here again or about the service framework, but essentially this might be some, something here that's hard to grasp if you haven't used it yet. But this is the service provider, which is part of the toolkit and the service framework. And inside there is the camera service, and you will see that here is where is the camera bounds module. It's registered to the camera service, and that way it's available at runtime. So if you want to learn more about that, I suggest looking into service locator pattern and also specifically into the service framework and how it makes use of that pattern. Also, throw me any questions you have regarding this, of course. That's it, everyone, for this session. I hope you could take something away from it. In this brief session, we just took a look at a very common problem in VR applications and games especially. And then we discussed and implemented an idea how to solve it, basically giving you a blueprint to extend it and make your own custom solution and implementation with some more hints to the player. But essentially, you now have a way at hand to know when your player leaves your play area, your play space, and you want them to come back into your designated area. So yeah, I'm looking forward to some questions and connecting with everyone. Do send me your questions in Discord, and yeah, have fun and enjoy the Global XR conference.